Hello and welcome to today's webinar with NetApp. I'm your host, Katie Bavoso from Technology Advice. Today, we'll hear how the powerful combination of Apache Kafka and Apache Spark can streamline machine learning workloads in real time. In this webinar, you'll learn the fundamentals of real-time machine learning, the biggest challenges facing data teams, as well as the optimal usage of Apache Kafka and Apache Spark, and their unique strengths and capabilities in the context of real-time data processing and analysis. And if you have any questions throughout today's presentation, please add them to the Q&A feature. And feel free to connect with us in the chat feature. Let us know where you're from and why you're here today. I'd now like to welcome today's presenter, Isham Kanish, Product Architect at NetApp. Take it away, Isham.
Thank you, Katie. Really excited and really happy to be here. So welcome everyone to this session. I'd like to take you through today Apache Spark and Kafka and how we can combine these two frameworks to get a building block for a real-time machine learning platform. Isham Kanish, OSS Product Architect with InstaCluster by NetApp. I have had different roles in the data industry, so I'm talking today as a practitioner. So our agenda for today here, it's pretty light, I hope concise. As Katie mentioned, we will go through the fundamentals of real-time machine learning. No need to go to big definitions, but just through a real-life use case. We'll then again look at the biggest challenges that are faced by data teams where they're dealing with machine learning in real-time approaches. And we finally see how we can use Apache Kafka and Apache Spark in an optimal way to tackle some of these challenges that are raised by real-time machine learning. So as I said, let's have a look at this kind of recent approach of real-time. Recent is a bit subjective, but in this case, let's take an example here. So I cycle every day from home to office, and just like a basic question that maybe is raised every time I take my bicycle out is, what is the shortest, the fastest cycling route I can take to get to the office? Additionally, I want to avoid traffic, like any urban or big cities. There are a lot of traffics on my way to the office, and like ultimately, by cycling, I want to stay healthy and I want to avoid all like the pollution exposure through my road. So this is like, I think millions of people around the globe are affected about this, especially as I said in urban and big cities, is how do I get from point A to B by avoiding my pollution exposure, by having a safest and shortest and yeah, quickest, I would say, road from A to B. So this question here, by the way, this doesn't have an answer yet. There is no solution. There are a lot of initiative using open source, but we don't have an answer, or there is no solution out there to give a proper answer to this. So as you can imagine that I usually, in average, take me an hour to cycle from my home to the office. And during this hour, a lot of things can happen, sorry. And they usually happen. So if you think about it, these air quality indexes are usually affected by traffic. So in order to get an answer to this question, we need to combine different sources. We need to be able to get information about what's happening and what's happening right now. This is why, I mean, this is what we, in a nutshell, this is what, at least here in this presentation, I mean, about real time. Again, like it's near real time to be more precise because there are different levels of latency when we talk about. Yeah, real time machine learning in this case is just the the application or the usage of machine learning to generate or to adapt based on the changing environment. So what I mean here is I need to, going back to my example here, I need to make prediction or rerouting a recommendation based on an event. Let's say a road closure or accident happened or an event is happening right now. So this is what I mean, at least here in this context, about real-time machine learning. So while we need to tackle this kind of problems is somehow we need to the possibility mechanism in place to ingest all these data sources, and we cannot list all of them, but as you can imagine and guess, whether the more precise the better. Traffic congestion, traffic jams, this causes, as I said, affect the quality of air and the state of dedicated cycling routes. In my case, matters a lot, because if I'm cycling dedicated cycling route, it's better than going to cars and trucks roads, and maybe other dozens of other factors that we can consider, like, as I said, mentioned already, special events happening or any other related thing um, happening in the city. So just for the sake of simplicity here in this case, to keep up this list of data sources. So once we identify the data sources, we need to combine this. We need the capability, sorry, to combine this, to ingest this data in real time and feed this to this big system and have this predictions or have this recommendation about routing the least air pollution exposure routes in real time. And before we jump to this, there is a building block. There is a building block we have to have in place in order to start thinking about more advanced modeling and machine learning, I would say. So the streamed data processing, which has been around for decades now, is just a computing architecture. It's helped to process and analyze continuously, ingest and process and analyze data streams. So having this in place will allow us to process data in real time or near real time, as I mentioned already. For this allow us to get insight or responses to the changing world. And obviously, I mean, at least for practitioners, stream data processing involves a lot of complexity, a lot of tooling, a lot of frameworks, and two of them today we are going to talk about are Apache Kafka and Apache Spark, and we will talk about these two frameworks in a complementary way. How we can combine them to get the best of the two worlds. So, and in order also to build this target machine learning platform to solve this problem, at least in our case, we will focus mainly on the unique strength and power that the open source will bring in this. And if we look at this kind of MVP or a target design for this real-time machine learning platform, you see a myriad, you see, a lot of tools combined together in order to solve this problem. So this is like a really complex field, and it has a lot of intrications. I would say it has a lot of requirements, and open source is key in this case to build this platform and solve this kind of problems, as I said. So if I move on to the next part of this presentation, and I want to list and discuss few challenges that are faced by data teams. And when I say data, it's data teams in a more generic way, or people or professionals involved around building, ingesting the data, building the platform, building models, serving these models to solve real-time machine learning problems. So one of the, I'd say, an inspiration, at least for me, is Ship Yuan. She has been doing a lot of great job around this real-time machine learning field. She conducted a lot of surveys and interviews with tech companies. She wrote a book, again, like a really interesting approach. She has been extensively writing and talking about these aspects. And if we list like two sets of challenges here, I would say we have the challenges that are inherently coming from data science side on from the modeling side, which can range or includes things like future features or engineering, incremental learning, which is pretty much a new topic, hot topic, model updating, data drift and model drift, and performance evaluation and MLOps, just to list these few challenges here. On the other side, we have challenges that are more related from a platform or infrastructure side of things. So as we mentioned, stream processing, scalability is really important. Latency similarly is a key when we're dealing with machine learning. We want to reduce it as much as possible, and things that you need to put in place in order to have a machine learning platform that is resilient and robust. Things like monitoring, alerting, and uh, how do you train your model? How do you serve your model? These are, as I said, more like from the infrastructure side of things. So, I mean, one of the at least conclusions, and it's a something that agreed on upon from a lot of practitioners in the field, is that the challenges, or at least in our experience, are largely an infrastructure problem. So the reason is, I say, is that this complexity raised from fact that we have a lot of tools to put in place, combine them, stitch them together is complex. From our perspective, real-time machine learning challenges are mainly infrastructure problems. And the reason is behind this is you have a lot of tools to combine together, to stitch together, make sure the whole platform works properly. This is still a major challenge for a lot of data practitioners. And among these challenges, I would say the critical aspects in real-time machine learning are the freshness of the data, which will allow you to get fresh features. Other things like the reliability of the data, the pipeline for your ML models. So we're really thinking that by combining Apache Spark and Apache Kafka, we can achieve both low latency and high scalability. Just to list these two major aspects of real-time machine learning. We are gonna focus here in the rest of this presentation on these aspects. And I don't think we can elaborate on all of them, but I try to just scratch the surface on a few of these subjects here in the rest of the presentation. So how do you optimally use Kafka and Spark combination for real-time machine learning? I would say here that we will reiterate that Spark and Kafka integration is really important because one of the key thing is their native integration. They allow for scalability. They provide combined together. They provide a real-time processing power or functionalities that are the best in class so far. They are built for fault tolerance. When you're building a platform, this is a key thing to consider. They integrate well with other system. They were born, I'd say, at the era of Hadoop, but they are really still kind of well maintained and well integrated with the most recent frameworks and open source technologies. And both of them are really key for supporting complex transformation, which are key in any machine learning initiative. So if we move a bit on some of these aspects and okay, so key factors to consider. In this case, we are looking to reduce the latency and increase the scalability. And to do so, it can be challenging. It will be challenging. So we have to go back to our basis and good practices and uh, things that have proven already successful in building systems and softwares and platforms. So I would say, as a rule of thumb, know your data sources. What are the data sources you will ingest? How they are evolving? What are the SLAs around your data sources? What are the volume? Is there any seasonality effect in the way the data is produced? Are you using an API? Is it evolving? So this is really kind of, again, common sense, but it's really, really important to consider this before starting or embarking in journeys in machine learning and specifically the real-time approach, real-time side of machine learning. Yeah, I'd say security comes in second, but it would be considered as the most important thing here. Security should be there by design, so always think about ways and put in place the best practices to secure whatever you're doing. It's really important, if not the most crucial thing to put in place. Deployment strategies. So we will come back to this in a few minutes, but just think about it. In this pursuing of low latency, we need to make sure that everything we deploy or everything we uh, use in terms of services, in terms of software, in terms of instances or VMs or processing should be as much as geographically co-located. This is really, again, like common sense, but it's important to put this in consideration for network performance and also selecting instances that if you are in a public cloud, the cloud providers recommend type of instances that have the best bandwidth, and this will all put together helping reducing the latency. Knowing your hardware requirement is key. Again, things like the back of envelope calculation or a trial or error are something you want to avoid. Um, so it's important, and we will have a look at this, dig into this a bit, and how we choose the right compute instances and how we can again reduce the latency and improve the scalability. Monitoring is really important, and don't think about monitoring just as a mechanism to uh, alert you or raise issues when they already happen. In this case, think about a monitoring approach that is more proactive, and you're building a real-time machine learning. So try to build a real-time monitoring system around it to be able to capture any sign of failures, any issues happening, whether from the data ingestion, the pipeline side, or the inference or the serving side. So let's just here take some time with specifically things to watch out where dealing with Apache Spark when deploying Apache Spark. So again, I cannot uh, put emphasis enough on the cluster's overall configuration. This is really important. And once we have, say, the infrastructure in place, the cluster in place, we need to think about Spark configuration and think about the parallelism with the respect to the sources. I mentioned this, that we need to think about the data sources, how they evolve, what is the volume, what is the frequency of updates. So think about ways to always keep your parallelism with respect to the data sources. Shuffle and partition. This is an ongoing, I would say, challenge for Spark, but it comes again to common sense and best practices to put in place to avoid issues like spill and shuffle issues. Think about the approach you want to put in place. Again, this is something really common. You're going the stateful or the stateless road. In our case, what we experimented is the stateful, so it raised some more complexity and more challenges, things like checkpoints. And we will linger, we'll elaborate a bit about the transformation here and what we recommend. So from Sting perspective is where do you write your data? Is it something you just want to dump somewhere, or your data is in motion? It's still living, it has to go to another pipeline. This is a really key for the whole end-to-end, I would say, pipeline from ingestion to serving. Just to take again this recommendation about the right sizing. So as you already know, if you are a data practitioner, a lot of these comes to continuous and repeated exercise, and knowing your data is key. Focusing on parallelism in relation to the source, as I said, it's really something that matters in our case. It helped a lot to figure out how do we best configure our cluster and the application itself, the Spark configuration level. So remember that streaming is CPU or compute CPU bounded, but in our case, where you're doing stateful approaches, state matters too to avoid spills. And we have seen most recently, I mean, with approaches like deep learning models with relatively long training and inference time. So in that case, try to avoid burning all GPUs on just one simple transformation or modeling. So try to mix as much as possible CPU with GPUs when it's possible to do. Latency, again, As I mentioned, Spark configurations are key to consider here. So think about ways to optimize this by, I'd say, gaining milliseconds here or there. So goes back to, again, things like the latency number, sorry, every programmer should know. So go back to the fundamentals in this case and the Spark best practices and best configuration. Sub-second latency expectation are really hard to get so far. It's still work in progress, but there are some few kind of good signs or pointers that we can achieve sub-second latency in really I'd say still challenging way, but it's achievable with some degree of effort and investment. Mentioned this already, stateful vs stateless pipeline. It's important to know the difference and choose the right approach. In our case, a lot of aggregation, a lot of deduplication required stateful pipelines. So in this case, you have to watch out for the complexity that stateful pipelines will add to your whole end-to-end pipelines. So consider the following. Use only simple computation involving data transformation or enrichment. Avoid joins, stream joins. This is something we cannot always avoid, but think about design your code, design your transformation in a way that your computation are simple as possible. Always use a message bus. In this case, the pattern that we really it helped a lot is Kafka Spark structured theming Kafka. You may ask yourself, we are adding complexity. No, it helps us in some cases to reduce it. Again, this is something that it should be explored for each use cases, but it's really helped a lot to simplify the whole platform design and the code we deployed on platform. And for stateful, at least for Spark, for stateful pipeline, we recommend you use RocksDB as a state store provider instead of HDFS. Key factors to consider with Apache Kafka: you combine it with Spark for machine learning platform, real-time machine learning platform. An important thing here to consider, to keep in mind, is the hardware. So whether it's CPU, RAM, disk, and network and file system, these are really important to keep in mind. And one good starting point, and I'd say, and a good recommendation to follow is the Apache Kafka website, which contains a dedicated section on hardware and OS configuration. So it's worth to look at and follow with this best recommendation. So Kafka is massively scalable, and just sometimes in some cases to ensure that the application is scalable end to end with with low latency. Sorry, it requires some non-standard solution. So you need to adjust various configuration, but such variation and combination may kind of sacrifice one each other or kind of affect each other. So think about it like if you think about the batch or the buffer size increasing, one often means sacrificing the other. So again, Kafka configuration can be really tricky to consider. So think about things like the topic configuration, batching messages, as as well as increasing the number of partition. The compression is really important, and combining this together will help to get a low latency and, as I said, the scalability we're looking for in the context of real-time machine learning. So I don't think I can elaborate, at least in this session, on the Kafka side. We just scratched the surface. There are so many things we need to cover. So I'll keep it at this point here with these points we listed. And as a conclusion here, so real-time machine learning platforms are not fiction, they are reality today. And a lot of organization, a lot of our customers are really considering moving to real-time machine learning with real-time data processing as a building block. And the reason is that they can gather insight and they can respond quickly to the changing environment and business conditions. So yeah, streaming data integration allows for things like, as we talk about the use case about, how do you predict the best cycling route, for instance? How do you detect anomalies, fraudulent transactions? How do you predict predictive analytics for um, machines or industrial plants? So the use cases are limited, and I would say there is a lot of traction around real-time machine learning. So this is what we do at InstaCluster. InstaCluster has been supporting the move to open source. We said that open source plays an important role. I would say even the most important one, because we don't have any other option than using open source, and we're really helping our customer either starting their journey or um, getting their existing. So InstaCluster is supporting the move to open source by providing expertise and helping our customers in their journey, whether they are starting their journey, they're already well advanced in the field, in combining open source and using it in their day-to-day, I'd say, data platforms and data usage. So how do we do this? We know that the challenges uh, are really hard in terms of operating open source, scaling it, and hiring and retention of the skill set or the experts. So eliminate problem with SaaS offering. We also have support offerings around open source, and we have a rich um, expertise around open source technologies. So, so what InstaCluster delivers is a SaaS platform, whether it's for Apache Kafka, Apache Cassandra, or Apache Spark, also OpenSearch with this Postgres and Cadence. We provide consulting and support, and whether it's on the three major cloud providers, prem, we also help our customers to get the best from their open source platforms. So thank you very much for listening. I hope you enjoyed and you learned the challenges about real-time machine learning, but also you learned that this is possible. It's a reality today, and it's through open source technologies that it's becoming more and more a reality.
Thank you so much, Jim. That was really exciting to hear about. So let's take some questions from the chat. The first one that we have is Kafka streams and Spark structured streaming. How are they different?
Yeah, that's an interesting question and common question, I would say. So Kafka Stream is part of the core APIs of Kafka, and it fundamentally transform input Kafka topics into output Kafka topics with a lot of benefits. And similarly, I would say Apache Spark Streaming is also an extension of the core Spark API, which is scalable and fault tolerant that supports batch and streaming workloads. So they have differences, they have different use cases, but the key thing here, what we want to show is that if we combine them together, we can get the best of the two worlds.
All right, we've got another one too. How will this system integrate with other components of your infrastructure?
Yeah, uh, as I showed in the diagrams and in different um, slides, is that both Spark and Kafka were originally designed in a rich ecosystem, but they kind of evolve and they keep integrating well with an vibrant and new ecosystem. So I would say at the end of the day, they integrate well and they are designed to work well with a rich ecosystem, whether it's data sources, databases, processing power, and engines. All you need to understand is how you will fit them together into an overall architecture.
And the last question that we have from the Q&A is what are the benefits of streaming data integration with Kafka and Spark?
Okay, yeah, so I try to cover a bit of these benefits, but um, again, just in simple words, they allow you to um, build real-time analytics capabilities. No need to think about advanced real-time machine learning, as we try to cover, but just having the building block to do real-time analytics. This is really something important to take into consideration, something benefit that we didn't have, I would say, objectively before having Kafka and Spark. Other things like scalability and fault tolerance and latency that I tried to cover are also really important. And with this comes also something that I didn't mention, but it's really key, is the data consistency and reliability. That matters a lot if you want to be confident in the accuracy, and the integrity of your data analytic results.
Well, Ichim, thank you so much for your time and your expertise today. I really enjoyed being here. And thank you to those watching. If you'd like to learn more about Apache Kafka and Apache Spark and how NetApp can help you unlock more opportunities with these tools, you can visit instacluster.com. Once again, I'm Katie Bavoso, and thanks for watching.